In this lesson, we're going to look at what is a concave mirror. So there are three types of mirrors that you may have encountered in your lifetime. The first one is just a flat or plain mirror like you have in your bathroom or on the wall of your house. The one we're looking at in this lesson is a concave mirror. It's like a cave. You walk into the cave. That's how I remember it. And the last one is a convex mirror. You don't walk into this one. This would be the outside world here. So they're kind of opposites of each other. So concave mirrors, there's a few types you may have come across in your lifetime. Here's a few examples. By the way, the spoon, this is the one that is concave. This is convex. We're not looking at that in this video. So some shapes. Again, these are more some concave shapes you may have seen out in real life. And what's going on here is we've got radio waves in this case. They come in, they hit the dish, and they're reflecting to this point. And of course, there's not one. There's probably an infinite number of these waves, and they're all collecting here. And perhaps on our Bell satellite dish here, they're bouncing here, and they're being collected at this point. So what's happening here is your satellite receiver is collecting the signal at this point is being focused on, and that's why you're getting a good image. And this one, you might remember or have seen at football games or something. They point this at the field, and the sound gets amplified so they can hear what the players are saying. So in all three scenarios, these rays are converging at something called the focal point. So a concave device has a focal point. We need to remember that as we proceed. So a concave mirror is like a half circle. Well, why don't we just complete the circle? And if you know anything about a circle, there's probably a center of the circle, and leaving from the center of the circle could be some kind of ray. And this ray inside the mirror is just going to bounce around and keep bouncing around forever. So this is our center of the circle. So a concave mirror is going to have a center. We need to know that moving forward here. Okay, so for an image to form in a concave mirror, at least we have to have two light rays that are going to intersect with each other. So let's take a look here. So there is our concave mirror, and we're going to draw a line, and that line is generally meant to cut this thing in half. It is called the principal axis. So a couple slides ago, we learned about the focal point, and I'm just kind of ballparking that the focal point for this concave mirror could be right there. And we also learned about a center point, and there is our center point. So you want to see an image forming within the mirror, you need an object, and we're going to use this candle. This is a classic one in physics, and it's going to give off some light. And so we're going to have some rays. Now let's discuss the rays that occur and how images form. So the first ray of light goes from the top of the object through the center and then reflects back on itself. So let's draw that here. So that line goes through the top, through the center, reflects back. It's a little hard to see the reflection because it's on top of itself here. And this dotted line represents inside of the mirror. So it went through the top of the object, the center, and then reflected back upon itself. That is the first light ray. Our image is going to form somewhere on this line. Now, for the image to form, we need a second line. And the second ray of light goes from the top of the object parallel to the principal axis and reflects through the mirror and goes to the focal point. So there's a couple things going on here. So firstly, it's going to go and hit the mirror. It's going to reflect through the focal point. And again, you'll notice right here, we've got this dotted line. This is our reflection. So wherever these two lines are going to meet, we're going to have our image formed. So hopefully it's pretty clear our image is, our two lines are meeting right here-ish. So let's place our image. Now the image is going to go from the principal axis and downward to where the lines meet. So our image looks quite different from our object. And that's the whole cool part about a concave mirror is depending on where you locate the object, your image is going to look all weird. It could be upside down, it could be really big, it might not even be there, it could be small. There's some things going on here. Now I do want to note that there's also a third line that occurs with these diagrams. And it just sort of confirms what you've already know from the first two. So this one's going to travel from the top of the object through the focal point, and then it's going to come off the principal axis parallel. So let's see what that looks like. So top of the object through the focal point and then reflects back parallel to the principal axis. So we do have a dotted line here. And again, it pretty much converges where the other two were. So that just confirms where our image forms. So when it comes to these mirrors, we have 5 different outcomes, and that's it. There's only 5 results that you can find. So let's take a look at those 5. So So the first one is our object, and that's kind of what we just looked at in the previous slide. Our object is located well beyond C here. So there's our center, and there's our focal point, and you see that our object is way over here. And our image is forming right there. Again, it looks like the one we just did. So what we want to do with these things is we want to salt them. We want to talk about their size, and I'm talking about the image here. So we want to talk about the size of the image compared to the object, the attitude of the image, the location of the image compared to the object, and what type we've got formed here. So let's talk about size. Our image is way smaller than our object. So our size is smaller. Attitude is either upright or inverted. The candle's pointing down, so it's inverted. The location, again, that's where you break out a ruler, you measure this line, you'd say, I don't know, maybe that's 50 centimeters, and then you measure from here to the mirror, and maybe it's 25. Well, clearly the image is closer, so that would be closer. And when it comes to type, we've got our real world over here, and our virtual on this side, and our image is appearing in the real world. We have a real image. So there's your first outcome. Second one, object is located at C. So there we go. The image and the object are lined up, and you can see that we have our conversion point here. So again, we're going to salt this one. So the image, if you look at it, it's maybe a little hard to see because it's somewhat overlapping, but they are meant to be the same size. The attitude is inverted. Location is the exact same. And again, our type is real. It's in the real world. So we'd actually need like a piece of paper, and you have to place it right here, and then you can actually see the image of the candle. Third one, object is located between C and F. So all that's happening here is we're moving closer to the mirror. So there is our object is right here. It is now between C and F. And you'll notice that our lines are now intersecting right about there. It was kind of ballparked a bit, but there is our image. So again, we'll salt this one. So our image, to me, it looks way bigger. So our image is larger. Our attitude is it's inverted. It's upside down. Our image is way further away now to the mirror. And we are still in the real universe here. This is the most bizarre case of them all. So our object is located at the focal point. So when you put the object at the focal point, you'll notice that these two lines, the green and the blue line, are parallel to each other. Parallel lines never meet. So if these two lines never meet, then we have no image forming here. So what I'm saying is, if you stood at the focal point of a concave mirror and looked into it, you would see nothing. There would be no rays of light meeting each other. You would be like you weren't there. So if you tried to salt this one, there's no image, so there's no salting. Weird. And our last one is the object is located between F and the mirror. So now we've got an image appearing actually in our virtual universe. Our image is no longer in the real world. We're going to salt this one. So our image appears to be a little bit larger than the object. The candle's larger. Here it is. It's upright. This seems to be the only case of a concave mirror where your image is upright. Remember, everything was inverted before, or not there. Our location it's a little further away. They're pretty close though. And our type is now virtual. And so anything in the virtual world here, you can see we've got dotted lines. Our image isn't really solid. It's just meant to represent an image that's inside the virtual or the mirror universe. Those are your 5 outcomes.